Hello everyone. Today we'll see microscopy. So, to read about some history about this microscopy, we should always thank our ancestors. Like Dr. Antony van Leeuwenhoek was the first person to use a simple microscope with one lens similar to a magnifying glass. It is capable of actually 50 times to 300 times magnification. Then Robert Hooke built compound microscope with multiple lenses. But finally, Joseph Jackson Lister, father of Joseph Lister, our father of antiseptic surgery, made the significant development and invented the modern compound microscope which is in use nowadays. So what is meant by a microscope? As a definition, a microscope is an instrument that enables us to view smaller objects that are otherwise invisible to our naked eye. Means it magnifies. So the terms will be explained later. What is microscopy? An act of using microscope, the instrument, to visualize the smaller objects are called as microscopy. Now we are supposed to know some introduction about what is the magnification power of human eye and what are the sizes of different sizes of other organisms which are said to be the microorganisms that are not visualized by the naked eye. Naked eye means unaided eye, without any power, without any help. How we can see the microscopes, how we need. What is the average size of a bacteria? It measures about 0.2 to 1.5 micrometer in diameter. So they are measured in micrometers. The length can be in 3 to 5 micrometers, whereas the viruses measures in nanometers. You should remember, bacteria are measured in micrometer, viruses are measured in nanometers, parasites are measured in millimeters. The few protozoans, which are unicellular parasites, are measured in micrometers. Likewise, fungi. The fungi can also be measured in 2 to 10 micrometer, and the length can be even in centimeters. So the average size of a bacteria is 0.2 to 1.5 micrometer. The viruses can be 20 to 300 nanometers. Okay. Now we will see some terminology that is used in the microscopy. So what is mean by wavelength? Wavelength is the distance between two adjacent crests of the waves, the light waves. What is mean by resolution power? Resolution power is the ability to produce separate images to closely placed objects. Next, what is the numerical aperture? Numerical aperture is represented as the maximum number of waves absorbed by the objective lens. Next, what is the refractive index? Actually, refractive index can be otherwise said as the index of refraction, and it is a value calculated from the ratio of the speed of light in a vacuum to that in a second medium of greater density. Means it is it can be used in a calculation like n, that is the refractive index, is equal to c by v. C is nothing but the speed of light, v is nothing but the phase velocity of light. What is meant by the magnification power? Magnification actually is a process of enlarging the image of the specimen, and it can be calculated by multiplying the objective lens magnification power and ocular lens magnification power. For example, ocular lens magnification power is 10x, and the magnification power of the objective lens, for example, 4x objective lens is 4 times, 10x is 10 times, 40x is 40 times, and oil immersion is 100 times. The total magnification power now is equal to, if you see the object in a scanner, then it is 4 multiplied by 10. That is magnification of your objective lens scanner multiplied by magnification power of the ocular lens. So it is totally 40 times you are magnifying the original image. If you are seeing in a low power, that is 10x objective lens, then your total magnification is equal to 10 multiplied by 10. First 10 is the magnification of your objective lens, 10x, and Second 10 is the magnification power of the ocular lens. So the total magnification is equal to 100 times. You are magnifying the original image. So when you see it under oil immersion, the total magnification power is equal to 1000 times. So the resolution power, the magnification alone is not enough. We need the resolution. Resolution means how actually the adjacent cells or the images can be clearly seen. The clarity is also important. So the resolution power of human eye is 200 micrometer. The light microscope is 0.2 micrometer and the electron microscope is 0.5 micrometer. What are the different types of microscopes? Microscopes can be broadly classified based on the source of light as light microscope and the electron microscope. Further, the light microscope can be classified into bright field and dark field. So the bright field microscopes are nothing but our compound microscope, fluorescent microscope, phase contrast microscope. So totally we have compound microscope, fluorescent microscope, phase contrast, dark ground and electron microscope as the different types of microscopes. What is compound microscope? Compound microscopes are nothing but currently we are using the compound microscopes. So it has an inbuilt light source. We don't need the sunlight as a light source. Inbuilt light source is there, and it has a different parts like mechanical parts, magnifying parts and illuminating parts. So what is the principle behind this light microscope is light microscopes, the rays from the light source pass through the iris and fall on the specimen. The light rays are gathered by the objective and magnified image is formed at last. So the magnified image depends on your magnification power and the ocular lens power. So what is the uses of compound microscope? They are used to view specimen direct examination for presence of microbes that are not visible by the naked eye. And we have 3 to 5 objective lenses here. Maximum magnification, we can have a magnification of about 1000 times. Even the stained smears can be used here. Next we will see the phase contrast microscopy. What is this phase contrast microscopy? Here the cone of light that passes through the cell, some light rays are bent due to variation in density and refractive index within the specimen and retarded by 1/4 of the wavelength. Means inside the cell we will have different wavelengths of the light rays that is coming out based on the refractive index of the object that is present inside the cell itself. Okay, the undeviated light rays strike the phase ring. Deviated rays miss the ring and pass through the rest of the plane. Background is bright while the unstained object appears dark. If you see this picture, the light rays go through the condenser, then the specimen. Example, the bacterium is specified here in green color. So here the one which is been tracking the bacterium, okay, will be reaching the phase ring, okay, and through the objective lens it will be visualized in the ocular lens. So here the deviated ray is half wavelength out of phase. The ray deviated by the specimen is 1/4 wavelength out of phase. Hope you will understand this phase contrast microscopy. So we can easily visualize the internal organs, the organelles inside the specimen, the bacterium or the cells easily in a live solution. Okay. What is the working principle of this phase contrast microscopy we have seen? So what is the uses of this phase contrast microscopy? It enables to show components in a cell or bacteria. It is an established microscopy technique in cell culture and living cell imaging tool. It enhances the contrast between intracellular structures having slight differences in the refractive index. One of the major advantages of this microscopy is that living cells can be examined in their natural state without previously being killed or fixed as like in our electron microscopy. Next is the fluorescent microscopy. In the fluorescent microscope, we do have two filters. One is the excitation filter and the other one is the barrier filter. Here we can either use the fluorescing dyes to illuminate and fluoresce so that it can be visualized. What is the working principle here again? If you use a fluorescent dyes, it will be exposed to the UV rays that becomes excited and it fluoresces. Okay, that is, they convert shorter wavelength rays into longer wavelength light. That is the exact principle of the fluorescence. Even that is used here in this microscopy. Mercury lamp, or here nowadays LED also is available. Mercury lamp emits rays that pass through an excitation filter. The excitation filter allows only shorter wavelength UV light to pass through. The exciting rays get reflected by the dichromatic mirror, fall on these specimens stained by the fluorescing dye. Barrier filter removes remaining UV light or blue or violet light, that is a shorter wavelength, and enables the longer wavelength light alone to pass through the objective lens, and it is seen in the eyepiece as a fluorescence. It has two types of fluorescent microscopy. One is epifluorescence microscopy, which is of simpler form, and the confocal microscopy, and advanced design. This epifluorescence microscope has some applications, like it can be used for the autofluorescence, like the cyclospora, the parasites can be examined in the epifluorescence microscope. The microbes that can be coated with the fluorescing dye, like acridin orange, oramen or rhodamen, that can also be seen with the epifluorescence microscopy. And immunofluorescence microscopy, the fluorescent labeled antibody helps to detect our antigen. Likewise, fluorescent labeled antigen can be used to detect the antibodies, and for that application also epifluorescence microscope can be used. This confocal, the advanced microscopy, uses optical sectioning to get better resolution of the fluorescent image. Here the magnification is very, very high in case of confocal microscopy. Next is the dark ground microscopy, otherwise said to be DGM, otherwise said to be dark field microscopy. What is this dark field microscopy, and what is the working principle of this is, object appears bright against the dark background by use of a special dark field condenser. Here in the condenser we will have a central opaque area blocks the light from entering the objective lens. The peripheral annular hollow area, it allows the light to pass through and focus on the specimen obliquely. The light reflected by specimen enters the objective lens. Unreflected light does not enter the objective. So the specimen is bright and the background appears dark. What is the uses of this dark ground microscopy is, the dark ground microscopy produces a clear image in a dark background. It is very simple but effective technique for observing live and unstained biological specimens. No sample preparation is actually required, that can visualize the living cells. Useful in diagnosis of Treponema pallidum that causes syphilis, Borrelia, Leptospira. All the spirochetes motility can be easily seen with the dark ground microscopy. What is electron microscopy? It is actually invented by German physicist Ernst Ruska in 1931. Here the source of illumination is the electrons. There in the light microscopy, the light is a source of illumination. Here the electrons are the source of illumination. Here the wavelength of electrons is 1 lakh times shorter than visible light photons. So that gives a better resolving power than the light microscope. It is of actually two types, the transmission electron microscope, shortly called as TEM, and the scanning electron microscopy, shortly called as SEM. And we have a featured difference between light microscope and electron microscope. The features are highest practical magnification, that is of 1000 to 1500 times in the light microscope, whereas it's about 1 lakh times in the electron microscope. The best resolution obtained in light microscope is 0.2 micrometer, whereas in electron microscope it is 0.5 nanometer. The radiation source is light here and electron beam in case of electron microscopy. The medium of travel light microscope uses air, whereas in electron microscope high vacuum is a medium of travel for the electrons. The specimen mount should be in the glass slide, whereas in electron microscopy it should be in the metal grid, usually copper. Types of lens, here is a glass and there is the electromagnet. Finally, the atomic force microscope. It is very advanced microscope that uses scanning probe technology to study the cellular structure very deeply. The resolution power is mesmerizing. The fraction of nanometers is the resolution power of the atomic force microscopy. The resolution power for our compound microscope is in micrometers. Okay, the resolution power of our electron microscopy is in nanometer, whereas for atomic force microscopy it's in fraction of nanometers. So finally, hope this post helps you to read about microscopy, the basic level. I didn't go in depth about the transition electron microscopy and scanning electron microscopy and their pathway, how it works also. If you like this post, subscribe the channel, like, and press the bell button. Thank you.